Well, hello everyone. Welcome to our channel 361 Physics. And as we have mentioned previously, that we are now focused to help all of you for your entrance preparation. And here we are presenting the next video of MCQ related with the dimension formula. Okay, so now let us begin with first question. And here in the first question, it is asked that the dimension or correct dimension of magnetic flux. Which is the correct dimension of magnetic flux? There are four options. So first, let us see how we can find this. Okay, though we have to remember all of these, but uh, if we know the way how to find it, then we will get the correct answer with proper confidence. Okay, so let us see. First we have to know that phi is the flux, so phi can be written as ba, and here b is the magnetic field. Okay, then and this is what, this is the area. So as we know that a dimension of area is L square, so this is quite easy. Then we have to find the first the dimension of B, that is magnetic field. Okay, so here we have to use the Lorentz formula, and from the Lorentz formula we know that F equal to BQV, and here we can mention sine theta, but the maximum Lorentz force is BQV. Here B is the velocity, its dimension is L t minus 1. Okay, and Q is the charge, so its dimension can be written as the product of current and time. Okay, so 80, this is this one. And what is this? This is force. So the dimension of force is m l t minus 2. Okay, so after using all of these, we'll get the expression for b, or dimension of for b, as m t minus 2 a minus 1. Okay, and after using this particular dimension here and multiplying by the dimension of L square, we'll get the dimension of phi, and this is m L square t minus 2 a minus 1. Okay, so here we get the knowledge of dimension of phi as well as the dimension of B. Okay, so uh, I suggest all of you just remember the dimension of phi, at least the dimension of phi, because it can be used to find the dimension of EMF as d phi by dt. Okay, so rate of change of flux is EMF, and it is also the potential. That's why phi, if you know the dimension of phi, you can find the dimension of EMF, or if you know the dimension of EMF, you can find the dimension of phi as well. Okay, so let us move to next question. And in this question, it is asked that the correct dimension of rate of change. Okay, so as in first question, we have to utilize the dimension of phi here to find out the dimension of flux. So as I have already mentioned here, that rate of change of flux represent EMF, so we can solve it in two ways. One is just write d phi by dt and write down the dimension of flux and divide it by the dimension of time, and here is your result. Okay, there is another method which is related with the Faraday law of electromagnetic induction, and as we know that rate of change of flux is directly proportional, here I have mentioned equal to, so directly proportional with EMF or potential. So if you know the dimension of potential, you can easily find out the correct answer. Okay, so I think it is very much helpful for you. Now let us move on to another question here. In question number 3, it is said that what is the dimension of B in this particular expression. Okay, so we have to find the dimension of B in this particular expression. Here Z is what? Z is the length of path. Okay, this is the length of path. That means this represents the length, and its dimension must be L. Okay, and in elaborated form we can write m0 L t0. Okay, so what we have to find the correct dimension for B. Yeah, then here we can see sine theta is dimensionless quantity, phi is as number, which means it do not have it does not have the dimension, as well as pi is also dimensionless quantity, which means the dimension of z and dimension of b must be equal. Yeah, from the principle of homogeneity, we know that if any equation is dimensionally correct, then left hand dimension and right hand dimension must be equal. So we can easily find out the correct answer, and the correct dimension of b must include the value of l only. That means the correct answer is c. Okay, here I have mentioned the explanation. If you uh, get any confusion, you can just read it. Okay, now let us move to another question. And in this question, question number 4, it is said that if A into B, this is quite familiar equation, and this is important equation of fluid dynamics. So A into B equal to constant, that means this represent the equation of continuity. Then what is the dimension of this particular, this product of A into B? So we have to know that in the equation of continuity, these two quantity represents here area, and this is velocity, which means if you multiply area with velocity, you will get here m square and then m per second, so m cube per second, which means volume per second. Yeah, volume per second. So we can easily find out its dimension. M is 0, l cube and t minus 1. So let us see. The correct answer must contain the dimensional value of L as 3 and T as -1. So correct answer is B. Okay, here is the explanation for this particular question. Okay, we have made a small video, and if you have any kind of suggestion, so please write in comment box. We are trying to make the solution and video as possible as short. That's why all of you can spend little time and get more knowledge of different aspect of physics. Okay, so if you get any kind of confusion, or if you like to know the solution of your MCQ problem of different topic, so please write it in comment box of our mm, YouTube channel. Okay, so please share it and subscribe it. Okay, stay tuned. Thank you.